I'm going to show you how I made 4 switches for the price of 1 real switch. In some ways making the accessible switch even more accessible. This is an accessible switch off the shelf that retails for about $40 to $60. And this is an accessibility switch that I made off of parts easily available on Amazon and a few custom parts, and should cost around $15. First, let me explain what a accessibility switch is. This is generally just a really broad general tool for making electronics more accessible. It's just a single interface switch that has this really generic 3.5mm audio style plug that can go into pretty much any type of device. And one of the key features is this really broad surface that's really easy to press. Microsoft sells these. They can connect to certain Xbox controllers, and you'll pretty much see these anywhere there's equipment that's meant to be more accessible. So before I dig into how I made a cheaper version, let's talk a little bit about how this current one works. So I bought an accessibility switch called the Jelly Bean from AbleNet. This seems to be like one of the common models. This was $69 with shipping. So let's try and figure out why this might be so expensive, and if there's a way to learn a little bit more about how it works, and maybe it tells us a little more about how we can maybe make a better one. There's, from what I can tell, one molded part that actuates, and it also has the threads to hold the cap. And there's a lower molded part that basically is the housing, the mounting features, and then the real only bit of wizardry in here is that guy. And I think that is a limit switch. Really cheap, off the shelf, nothing custom. And it basically just sits there in an open position. So the 2 contacts at the end are open and they're not connected. And then when it's depressed, these complete a circuit. So the machine can know that the button's been pressed. Let's go a little bit deeper. I just did a little Googling of the number that's on this switch. And this is, yeah, a totally standard off-the-shelf limit switch. Retails for 98 cents at volume 1. So as you increase the volume, that price is going to go down to about 50 cents. We're looking at $1 for the cable. Let's be generous and say $1 per part, maybe $10 here at really low volumes. But again, these are molded parts, so you could really get this down quick. Either way, it seems like there's room for improvement, or something I don't understand. All right, so after kind of taking that thing apart, I think what we're kind of looking for is any sort of button that has a wide surface. And we could probably start from there and then figure out how to get the correct cabling. The first thing I bought was this button set. Looks like it has a really wide surface. Definitely looks like it has like some pressing motion. This was, I think, $28 for a set of 4. So that's $7 per switch. this is what you get in the box. As advertised, kind of a nice big switch. It's got a slot for a battery. It's got like speaker holes. There's probably an LED in there. And right away, I got some decent up and down motion. And I think that could be turned into a good switch. So let's take it apart. That one's just the battery. And it looks like we have maybe 3 injection molded parts. And here's the business. And we have a circuit board here, which is way more complex than the little switch, the limit switch that's inside the Jelly Bean. Different switch mechanism, and then some things we'll be able to ignore. There's a speaker here for some of the games or whatever you can play with this, and there's also the connections to the battery. So I've already disconnected those and converted this switch. And oh yeah, and you can see the LEDs. There's actually 2 of them. One LED there and one LED there. But the real meat of this, and the part that we need, is actually in the center here. And it's this sheet metal piece that looks kind of weird, like an X. And it's actually like scotch taped on. That's called a dome switch. And if you press that, that'll feel like really familiar to anyone who's ever pressed it. This is what's behind like ATM switches or any sort of tactile switches. It's actually pretty similar feel to a home button on the phone. So it's got that feel, and that's what ends up actually creating the switch. So you have this big column that's sticking out. The column comes in contact here, and once I get the motion. Let me explain a little bit more about how the dome switch works. May not be super clear just by looking at it, but if I peel it back, there is a ring going around that goes to some part of the board, and then a center kind of circle here. And what the dome switch does is when you press, these are electrically connected. And the way it achieves that is with this like cleverly, slightly deformed piece of sheet metal that has a little proud pin in the center. And then the way it's shaped, it actually gets deformed when you press it and then can pop itself back off. So you can see when that little center is pressed, it's connecting that outer ring and inner ring, and when I let go, the spring force of the sheet metal pops it open and they're disconnected. It's a really inexpensive way to mass produce a switch, and no mechanical parts other than the steel here. So the biggest thing that's missing from getting us all the way to replicating the Jelly Bean is the cable. You notice the one that came from Amazon, the Simon Says switch, doesn't really have that. So we're gonna have to purchase that separately. They're really easy to find. You just search mono cable. You can even find them with just like the bare ends, but it actually was cheaper to get the one that had like a giant connector that I won't need. So to find out where exactly on the board I can hook up to gain access to the dome switch, I have a tool here called a multimeter, and the multimeter, this specific multimeter can do a whole bunch of things, but one of the nifty things it can do is check for something called continuity, and that can be really useful for finding out where things like a switch close or when 2 things are electrically connected. So in practice, what that looks like is anytime there's an electrical connection between the red and the black wire here, it should have a little beep. So if I just connect them together, I get some noise. So after a bit of probing around on this board, it just seemed, I don't know, not too easy to find like distinct contacts I can use and solder to and just recycle this board. So although it would be probably pretty easy to eventually find somewhere to solder to this board, connect my cable, and then just be done, I went a little different route that I think can be even easier for some people, and if maybe makes this a little bit more accessible for some people to do themselves, and just maybe a little more of a project for me. I recently just got a PCB mill, so I can make really simple PCBs like this one, and I thought this would be a great project to try it out on. So I'm going to take this PCB off, take some dimensions, and actually recreate it in a 3D CAD software, and then design my own PCB that fits in the same spot and accepts the same dome switch. So the end product that came off the PCB mill is right here. When I line everything up on the board, or on the molded bit, it lines up such that if everything stacks up, everything's centered, and this will all strike the center. Let's put it back together. One other thing I had to do was cut a little slot in here with a little saw, just to make it so I didn't have to drill a hole and worry about desoldering the whole thing to assemble it. Test it out. So first the jelly bean, and next the cheapo switch. Works. While we're here, should just talk quickly about some of the drawbacks of the cheap switch. Not everyone has a PCB mill, but there are options for making PCBs at scale, and they're insanely cheap. So you could potentially get somebody set up with a pack of buzzers, the cable they need, and then that custom board. And they could assemble this themselves with a little bit of soldering. That's just the manufacturing side, but from the actual design side, there are some drawbacks. There's a lot less force required to press this button than this button. This is a much heftier press. And when you're thinking about the applications, perhaps somebody's pressing this with their with their elbow, or they're a small child, or somebody's pressing this with the side of their head. Having the extra force required to press the button to complete the task is going to be cumbersome and probably rule this one out for some people, and they'll much prefer this. The only other thing that's really stands out as a nice feature on this one that isn't on this one is the mounting holes. This one only has the rubber feet, but again, it wouldn't be too hard to add that kind of feature if we were doing something a little more customized. This really is just a proof of concept that somebody could make their own Switch for $10 to $15 cost, which makes it really easy for someone to mark that up to retail and still beat the $40, $50, $60 that companies are charging for these.